Hi there. My name is Jeff Martins. With me is Matt Wallington. And as we get started right now, we'd like to talk to you about this light bulb that I'm holding. See, at CPUsage, we think a lot about electricity, how great of a utility it is. We can screw this light bulb into just about any lamp, and it'll always work. We can take that same lamp and plug it into any outlet, and again, it always just works. Well, we have a vision for compute that looks a lot like that. Unfortunately, though, it's not that way today, and let me explain. Meet our friend Robert. Robert is the chief scientist at a biotech company whose customers ask them to analyze up to 100 million molecules every week. Because those molecules each take about 5 minutes to process, we know that in a single work week, they have to perform about 8 million hours of compute. And you know what? Robert's not alone. There's someone just like Robert at every oil and gas company, every media company, and every life sciences company across the globe. And they have teams of people that will spend months deploying software and writing tools and technologies to make hundreds or thousands of cloud instances work together. Well, at CPUsage, we think that's stupid. And that's why we're disrupting the massive industry of high performance and high throughput computing in the cloud. So here's how. At CPUsage, we allow any developer the opportunity to distribute virtually any high performance or high throughput application across any cloud at any scale in a matter of minutes, not months. And it's really simple the way our product works. You come to us and you configure a single sandbox, a single virtual instance. We take that instance and we automatically distribute it and replicate it across hundreds or thousands of compute nodes in the cloud. And then you do the equivalent of simply clicking start. It really is that simple. So let's think about that. You could do it the old way, the way that Robert and people like him are doing it, and you'll spend months. Or you can do it the CPUsage way, and you'll be up and running in just a matter of minutes. So with that, I'm going to turn things over to Matt, who's going to run us through a quick example. Matt?
Thanks, Jeff. So for this demonstration, we're going to take Blender, which is a graphic rendering tool that many people use. It works great on a single computer, and we're going to distribute that across 1,000 instances in the cloud, building a graphic render farm. So let's go ahead and get started. The first step is you log into our website, and you generate a sandbox, as Jeff mentioned. And this is where you specify the operating system of your choice and any tools that you'd like pre-installed, like Python or Ruby, etc. Once you have that sandbox created, you log into the sandbox and install and configure your application, the same way that you would do on a single computer in front of you. Once that application is installed and configured, you go ahead and you launch our CPUsage API Builder. And this is a tool that we've built to build a custom API specific to your command line application. And you do that as simple as adding or typing the command line arguments that you would normally type into that application. Once that's complete, you've built and completed your environment. Now it's time to actually submit that fire hose of data to the API. So can we switch the monitor, please? So I'm going to go ahead and submit compute tasks. And we're going to submit those thousands of compute tasks to render this video. And here you'll see that we are provisioning, running, deploying our application across 1,000 cloud instances, taking something that would normally take potentially months and doing it in a matter of minutes. Thank you.
All right, so it really is that easy. Could we switch back to the slides, please? Okay, so you're probably saying, Jeff, Matt, how many people really have to do high-performance computing in the cloud? Well, let me tell you something. High-performance computing is the unsung hero of the technology landscape. There's hundreds of thousands of customers across the globe that are performing these compute tasks every single day. And then there's high-throughput computing, something very similar, but actually a little bit more simple. And I can tell you that just about every tech company in this building today is doing that on a daily basis. And those companies are already spending big. So high-performance computing, online and offline, is already a $29 billion industry. And of that, $1 billion is already being spent in the cloud today, again, to do high-performance computing. So that's the market that's up for grabs with us. And of course, we're a platform, and I don't think I have to remind anybody in this audience that platform as a service is one of the fastest growing sectors of the cloud, with over 25% annual growth projected each year for this foreseeable future. All right, so why are we here today? Well, Matt and I and the entire CPUsage team, we're excited to announce that as of this very moment, CPUsage is in public beta. You can go to www.cpusage.com right now, and in a matter of a few minutes, you can be up and running at scale in the cloud. Today, we support Amazon Web Services, and over the next few months, we'll add support for other infrastructure such as Microsoft Windows Azure and Google Compute Engine. After that, we're going to tackle the private cloud, where there's a massive opportunity for platforms to change the way that enterprises compute. So before we wrap up and walk off stage, I want to bring you back to this light bulb and remind you that at CPUsage, we have a vision for compute that looks a lot like electricity. We think you should be able to plug in any compute application, consume as much compute power as you want, without having to think about configuration, how the compute gets to you, or even where the compute comes from. We ask you to join us in that at www.cpusage.com. Thank you very much.
All right. Judges?
So building something sort of this aggressive and expansive requires a top team, and I didn't hear you mention anything about that team, so I'm wondering if you could tell us a little bit about who's come together to do this.
Sure. So our team is one of our greatest assets. We're a small team right now, just 4 of us. I come from a background in strategic planning and finance at companies like Synopsys and Nike. My co-founder here, Matt, spent about 10 years at Intel, and our lead engineer spent 16 years at Intel as a senior engineer. So we have a top team, and we also have great investors that are helping us do this.
To a not quite as geeky guy as I need to be to understand this, can you tell me what's so magic about what you're doing up in the cloud that enables this?
Matt, would you like to take that?
Sure. So what's geeky about it is just essentially the glue that we've put together. Built a really easy to use platform for people that aren't geeks that don't know how to do this. So, as a DNA researcher or a scientist, these guys are biologists. They don't want to have to think about how do I develop, I know how to run my tool, but how do I develop that to run across thousands of instances in the cloud? And so what we've done is taken that, abstracted away, and made it dead simple for them to use.
Is it realistic to think that those people at corporations are going to be running these tasks? Or, I mean, they have IT people at the company. I mean, you're going to have to convince the IT folks, right?
Sure, absolutely. So yes, it is realistic that they're running them. They're already doing it today. So as we saw, they're already spending about $1 billion a year running them in the cloud. And as we've been working through our private beta, we had one large publicly traded biotech firm. We had their VP of research come to us and say, I would like you to eliminate the gap between my researchers and the IT department. I want my researchers to be able to compute from their desks.
Okay.
But the sale is still through the IT person, the adoption that you hope for.
Right now, no. So the idea is that an IT person could set this up, but really what we're going after is that end user, that person that is doing the compute, is needing to run the compute. We don't want them to have to go through an IT department to do this. So we're abstracting that away, building tools to make it easy enough for them to figure out how to do it with very minimal experience.
So it sounds to me like you're just building a very thin layer on top of the cloud. Like you can just hit these API endpoints for AWS to spin up new machines and configure them with like Puppet or whatever. What is the defensibility of your product? It seems like it should be pretty easy to replicate this software layer.
Sure. From a business standpoint, one of the things that we've done is we've spent the last year plus becoming experts in all the technologies and tools that it takes to do this. So we've used technologies from Linux containers to virtualization to private networks to grid middleware. There's a very small community of people that know how to use the grid middleware that does all the job orchestration and resource management. So it is somewhat of a specialized task, which is why there's such a big opportunity for us. Another area that we're able to defend ourselves is that we've built a specific tool for high performance and high throughput computing. So we are a platform as a service, but we go after a very different market than what most platforms do. So for us, large scale is 1,000 compute instances, and for most platforms, 20 instances is large scale for them. So we've picked a market where we can become experts and where we know it's large and we know we can make a big difference.
Does AWS and Azure and whatever else, I mean, it would seem to me that this is the kind of functionality that, if I'm using AWS, that I'd want AWS to be offering me. I assume they'd have it. I'm surprised they don't.
Sure. So AWS specifically doesn't. They do a great job at providing infrastructure, but we all know the Amazon model. The Amazon model is to have razor-thin margins and do a lot of volume. So that leaves an opportunity for all platforms, not just us. And we've seen successes with a few other companies. Specifically, one of the major cloud vendors, their biz dev manager for high performance computing told us that we solve a problem that every single one of their customers has. So they could build it, but we think they should just buy us instead.
Now we know your strategy.
Not gonna lie.
How different is your product than something like EMR on AWS or Redshift? Like they are starting to provide these different technologies for users to do big data computation without worrying about spinning up all the machines.
Sure, Matt.
Sure, so a lot of those require you to know how to use those even. And so again, you would still potentially need an IT department that would have to figure out how to use those technologies and then port the user's application to work on that. Our goal is to take an application off the shelf, not have to put any custom code into it, not have to worry about how you would scale that across even those technologies, and just distribute it straight to the, build the custom API through our API builder and just distribute it straight to our grid.
So as Matt mentioned, we're not specific to any one application or technology, but we're also not specific to any one infrastructure. So we support AWS today, and in the next few months, we'll be adding support for other popular infrastructures. So as great as AWS is, there are customers that want to use other platforms, and we think some other platforms are pretty great too. We also have the ability to switch from one to another just like that by clicking a mouse button. So maybe you're computing at one infrastructure provider and a big weather storm hits the East Coast. You could switch to another infrastructure literally with a click of a mouse. All your jobs get scheduled over. You don't have to think about how you make your stuff work for that infrastructure. So we're infrastructure agnostic as well as application agnostic.
So you're pretty focused on computation, not as much on data. Is that correct?
So yeah, so we have a focus on transactional type workloads. So a lot of big data does come in that type of compute. So we are ideal for that, but we're also focused on the sciences where they do things like molecule analysis, but also the media like video encodings and graphic renderings.
All right, we're out of time, but that's CPU usage.
Great.